Okay, now we know there are three different averages in statistics. The first one, mean. The first one, mean, is just another name for average that we know. Right? So mean is just a technical terms in statistics, which means the same as what we have understood as average. The median is the number right in the middle of a list of numbers. Remember, the number has to be ordered from the smallest to the highest, then only you find out which number is right in the middle. Otherwise, you have a lot of different medians. Okay, so there's only one median for each set of data. And a mode is the one that shows you which is the number that appear most in your data set. So now I'm going to bring you to another slide which explains what is the relationship between mean and median. Why should we have two? And how do we actually use these two? Okay, so in a previous this slide shows you that if you have a data set and the data set has extreme values, that means you have some values which are relatively bigger than the rest or relatively smaller than the rest, then you don't use the mean as the center. You would prefer to use the median as the center. Now, why is it so? Earlier, we see that median is very stable. If we have extreme values on either larger side of the data or smaller side of the data, the median seems to be very stable. It won't be affected. Okay, so because of the stability, it is more appropriate to be used as an average to report if your data is skewed. Now, the next thing that I want you to let you see is what's the relation between the mean and median in the three graphs that we have. Okay, so in the last slide of last topic, we have a few graphs. One is the symmetrical, which is bell-shaped graph. So we have it here, I think. Yeah, we have a bell-shaped graph, looks like this, and we have one which is longer side on the right hand side, we call the right skew, and we have another which is left skew. Okay, so unless you draw this graph, you won't know whether it's which shape you get, right? But there will be a good news today that if you are able to find out what is the mean and what is the median of that set of data without you drawing the graph, you are still able to tell what is the shape if you were to draw the histogram. Okay, so now I'm going to explain to you using this. This is the table that you saw in previous lesson, right? 10, under 20, 20, under 30, and so forth. So this is a frequency you have. So I'm trying to draw it into a histogram. What is the shape of this histogram? You have a 3, you move up to 6, come down slowly 5, come down slowly 4, come down slowly 2, and that's it. Okay, so what's the shape of this histogram? So it seems that there is a longer side on the right hand side. So it is called right skew. Okay, it is called right skew. So you can actually see right skew from here, right? It goes up, then it comes down slowly down. Okay, so this is right skew. Now, this is the original data at the bottom here. So let's find out what is the mean and what is the median. So you just calculate, you add all the numbers and find out the average, the mean. I have it in the previous slide. The mean comes out to be 32.4. The mean is 31. Okay, so if I were to indicate it here, so let's say this is the 31 and 32.4, right? So 31 is very close to here. It's probably just here. This is 31. Okay, then I use another color. I put 32.4. It's very close. for this particular one. Oops. This is 32.4. So let's see. So you see that this is the mean, yeah? So this is the mean, and that is the median. Is mean higher or median higher? Mean is higher, 32.4. Okay. Relative to the median is slightly smaller. Right. So in this, you look at the x-axis, mean is towards the right hand side because this side have more values and there are big values here. So unconsciously, this mean has been dragged over to this side. So it's a little bit bigger than the median, right? So you have a guideline here. If you have the mean which is bigger than the median on the x-axis side, yeah, don't look at the height, yeah, don't look at the height, you don't look at the height, you look at the number at the x-axis, which I show you over here. The mean is 32.4, which is here, and the median is here. Okay, so mean is slightly bigger than the median. You would expect to see a right skewed graph without you drawing it, you know already. So you don't need to always draw the graph. Sometimes you just analyze the data, knowing what is mean, what is median. From these two numbers, you can know what's the shape of the graph. So you can look at this. If the mean is bigger, then it is right skewed. If the mean is smaller, then it is left skewed. If the mean and the median are almost the same, then it should be symmetrical. So you can use these two numbers to roughly know the shape of the graph. Yeah, I don't think everybody likes to draw this graph, right? So there are 6 graphs in topic 1 exercise. I'm not too sure how many of you have done it, and plus 3 in the exercise in the slide. So we have 9 graphs there. So if you enjoy drawing graph, then it's okay. So you can continue draw it. But if you find drawing graph, I think most of us do not want to draw graph if there is an option. Yeah, so you have this mean and median to compare with. So its mean is bigger, is right. Mean on the right, then is right skew. Mean on the left is called left skew. Mean and median is the same, then is symmetrical graph. Okay. Okay. Now we are done with this. Okay, I'm going to go back to this. We're done with the center. So apart from the center, we also want to know other parts of the data. So remember, when you arrange your data from the smallest value, this is the smallest value, this is the minimum, and that is the maximum. If you arrange your data from the smallest value to the maximum value, and the one right in the middle, we know it is called median. Okay, now we're going to split this data into 2 sections. Sorry, I wrongly pressed it. Into 2 sections. One is in the middle of the middle, in the minimum here. Okay, this is maximum. One is the middle of these two. Okay, another one is middle of the other side. Right. So now you see that the whole entire data set is split into 4 sections. So each section is 25%. So the first 25% at this 25th point, we call that 25th percentile, we call that the first quartile. Qua means 4, right? So quartiles mean we split the data into 4 sections. So at this point, this Q1 side, we call that first quartile, we call that lower quartile, or we use a symbol just Q1, right? So then you have another one, which is the median. So median will be automatically called second quartile or middle quartile. Okay, and the third one is called the third quartile or upper quartile. So the first quartile is also called 25th percentile, median is called 50th percentile, and the third quartile is called 75th percentile. Now you know how to find median. Median, the formula you use just now is I equals to half N, right? Okay, why half? Based on this 50, it's actually 100%, half of it, right? So now you can figure out what will be the formula for the I for first quartile. So first quartile is only 25th percentile, so it should be 25th over 100 n. 25th of the 100 n is just 1 quarter n. And 75th percentile will be 75 over 100 times n, and you get 3 over 4 n. Yep, so actually the formula is the same. So if the formula is the same, the rule will be the same as what I have explained to you. Now the top number is called the percentile. 25th percentile, 50th percentile, or 75th percentile. Let's look at the example. Find the first and third quartiles of the data. So first quartile, this one is Q1, yeah? So you want to find Q1. This one you want to find Q3. First quartile, the percentile is 25%. 25th percentile times the n. There are 19 numbers here, so you put 19 here. Then you get 4.75. According to the rule, it says if you don't get a whole number, then you round up to the next integer, which is higher than what you have found. So 4.75, you round up to 5. So the position of Q1 is the 5th number. So what is the value of the 5th number? 51. 51 is the Q1. The 5th position is the position of the Q1. Okay, so the answer is still 51. Now you go on to find out the third quartile. Same way, you get 75 here, you get 14.25 here, so you round to the next integer, which is 15. Okay, so 15th position is here, so the number is 88. So 88 is the third quartile. Let's look at another example where you end up with a round number. So first quartile is 25th, third quartile is 75. So both will be for 16 numbers. So the first one, you got a 4. So according to the rule, if you get a round number, then you take another round number, which is the next position. So you get 4th and you get 5th. Okay, and you find the average. So this is Q1. Next one, same thing, you get 12. So you find this out. So you're going to find the average of these two numbers, 12 and 13. 83. Okay, so this is how you find quartile. Quite similar to median, just that you just change the number on top. Yeah, P is 25th, 25, or 75. Okay, now we're done with the center and the location, position. Okay, we're done with the position, the center, or the 75th percentile, 25th percentile, all the quartiles. Now we move on to the next portion. Now, why should we know about this? If you have two sets of data, if we have two sets of different data, is it possible that these two sets of data having same average? I repeat, is it possible to have two sets of data having the same average? It is possible, right? So what is the difference between them? There must be something different, that they are different, right? Then what is the difference is variation. Okay, the variation here means how spread out is the data. Maybe the first one spread out. Okay, maybe the first one is from 1 up to 100. And the average is 52, let's say. The second set of data only range from 40 to 62 or 65, let's say. And you also get 52 as your average. So what's the difference? It is how spread out is the data that is differentiate these two sets of data. Okay, so we have some measurements here, the range, variance, and the standard deviation. So for the range, you knew it from the very first lesson. The biggest value in the data set minus of the smallest value is called the range. Okay, so let me go through one by one first, and I come back to this diagram. Right, so what is actually variation? You have variation if all the data are not the same value. Okay, some are bigger, some are smaller. All right, so basically, if you have smaller variability, the measures of variation, if it's small number, that means you have less variation. Right, so the first measurement is called the range. The range, you knew it from the first lesson, where you take the maximum value minus of the minimum value. So for example, the number of DVDs you have, the maximum number is 30, the smallest number is 0, right? The smallest number is 0. So what is a range? Range is just 30. Is it good measurement? Very easy to find. But if the maximum or the minimum is the extreme values, then you get a super huge range for the value. Okay, so it's not so reliable. Let's look at 1, which is more reliable. Remember the quartiles we have? So this is called Q1, this is a Q1, and this is a Q3. And this is where you have the minimum value, and this is where you have your maximum value, right? So if you want to disregard this, you don't want to take anything from the minimum or the maximum inside, then don't take all. You only look at here. Okay, this point is Q3, this point is Q1. So if you take Q3 minus of Q1, that will give you a range. That range does not include maximum, does not include minimum. So it will be a range to tell you that this is just a middle 50%. Yeah, so how much is this? This is the 50%, yeah, middle 50%. So this middle 50% range is called inter means between, quartile range. In short, we always use I. The I come from here. The I, Q, R. Okay, I, Q, R is interquartile range. So this interquartile range will solve the problem of range. So extreme values will not be taken into calculation. We already gotten this Q1 and Q3 in an example of this quartile, right? So now we just pick up the number 88 and 51. So interquartile range is so easy. You just take 88 minus of 51. That is 37. Same thing for the another example. Okay, now that is range and interquartile range. So now we move on to variance. What's the difference between variance and standard deviation? You have a population, you have a sample variance. You have the population standard deviation, you have a sample standard deviation. So no matter what you have, you always have two sets, yeah, in a pair, the population and sample. But what is the difference between variance and standard deviation? Standard deviation, look at this point. Standard deviation is a positive square root of the variance. So for example, the variance, if the variance is 25, then standard deviation is how much? It says standard deviation is positive square root of the variance. Positive square root of the variance. So it is 5. So if variance is 9, then standard deviation will be 9, and it will be just a 3. Okay. On the other hand, if you put the other way around, if the standard deviation is 4, then the variance will be 4 square, will give you a 16. Right, so that's how they are related. So when you know one of them, to find the other one is just very easy. Just square root it, or you just square it and you get the other one. So I always consider these two as just one. It's not two. So variance, it will be the square, okay, and standard deviation will be the square root. Right, again, because of the two circles we have two sets of data, two sets of formula again. The variance or standard deviation, the standard deviation of a population is called sigma. The standard deviation of a population is called sigma. Okay, this sign is read as sigma. This sign is read as sigma. So if you want to find standard deviation, you just get the square will be the variance, correct? The variance square root, and you get a sigma. Right. So this is the formula for you to find the variance. Just ignore it. I will show you another one. We are more interested in sample because population is too huge. So most of the time we don't really go into the population formula to find out population parameter because we don't have the data anyway. So most of the time we just use the sample data to calculate what we want. So when we are asked to find out the standard deviation for sample or variance, we are going to use a formula here, right? The formula that you're going to use when you do a hand calculation will be this. Okay, so once you get this is the variance, S square is a variance. Okay, S square is a variance. So you want to find standard deviation, you just need to square root it, then you get a standard deviation, right? Now what I want to do is I want to explain to you what does it mean by standard deviation. Okay, but this formula are not able to describe or demonstrate to you what is standard deviation. So I'm going to use this theoretical formula to explain to you. So after you understand what is standard deviation, when you do a calculation, please use this. Okay, so that is a shortcut formula. Okay, now what I'm going to show you is this. You have numbers. You are given 10 numbers here, 471050326. Okay, so with these 10 numbers, how do you find the standard deviation? In order to find the standard deviation, you usually have to start off with a mean. So you ask yourself, where is the mean? So I'm going to draw something here. Okay, let me just take it away. Do I have a bigger space? Okay, now I'm going to draw this. What number do I have? I have a 0 up to the largest is 7, right? So I have 0. It's too light. It's too fine. So I'm going to put the thicker. 0, 1, 2, 3, 4, 5, 6, 7. Okay, so there the maximum is 7, the minimum is 0. So now you can see that the calculation of the average comes out to be 3. So we are going to draw a 3 as the guideline. This is the mean, the average. Now we are going to look at how far all this number deviate from the 3. So the first number is a 4. So where is 4? 4 is here. How far is 4 from 3? Is 1 step to the right. Okay, 4 is 1 step to the right. How about 7? 7 is here. Is 4 steps to the right. Yeah, 4 steps. Then where is 1? 1 is here. 1 is 2 steps to the left. Left is negative, yeah. Then 0. 0 is here. Is 3 steps to the left. Then 5. 5 is here. How many steps to the right? 2. And 0. 0 is here again. How many steps to the left? 3. And 3 is XL is here. So 0 step from the mean. Then 2. 1 step to the left. And you have another 6. 6 is here. 3 steps to the right. And you have another 2. Have another 2, which is 1 step to the left. Okay, now if you have a calculator or you just use a mental calculation, add up all the number. Add up this number. This. How much you get? You get a 0, right? 0 means no deviation. Yeah, all the numbers are actually 3, which is not true. Some are on the left, some on the right, but the problem is some positive, some negative. So everyone will counter each other, and at the end of it, there's nothing left. So how to get rid of the positive and negative number? We are going to turn all the negative number to positive number. How do we do it? In mathematics, you can only turn negative to positive by squaring it. So if you want to square, we square everything. So we're going to square everything. You square 3, you get 9. You square 2, you get 4. You square, square, yeah? You square 4, you get 16. Now you square 1, you get 1. Now you square negative 2, you still get 4, positive. You square minus 3, you get 9. You square minus 3, you get 9. And you square 1, minus 1, you square minus 1, so you get 1 and 1. So now you add up all the number is no longer 0, right? So it will be 54. It will be 54. Okay, now these 54 numbers come from how many distances? From all the data points you have. So there are 10. Okay, so in other words, 54, if divide by 10 numbers you have, that will give you the average distance. Yeah, average distance is a squared distance, sorry, average squared distance from the center, which is the mean. Okay, 54 divide by a number, you end up with divide by 10, that give you the squared distance, average squared distance from the mean, which is 3. Okay, so if you square root it, that will give you the average distance without the square. Okay. Now you see that here they give 10 minus 1. That is a formula for you to find standard deviation. By right, there are 10 numbers, you should divide by 10, but there are some research has been done long time ago that say that it has to be minus 1. So we just follow the this formula, right? -1. So you -1, you still get average squared distance. So by square rooting it, you get rid of the square, becomes average distance. Okay, so the average distance, 2.449, means on average, all these numbers, okay, on average, all these numbers are about 2.449 steps away from 3. I repeat, on average, the 10 data values here is 2.449 steps away from 3. Okay, so that's how you explain standard deviation. But you see that it's a bit tedious to do all the calculation and all the squaring, right, and all the adding. So we do have another formula which you use hand calculation to do it. Okay, so this is what you do. This formula is just for illustration to explain to you what standard deviation is. So when you are done with that, you need to use another formula to do a calculation, which is much easier. So I'll just put it bigger. This is a formula. It looks complicated, like it is more complicated than the other one, but when you start to do it, it is actually easier, right? So do you know what is n? You know what n is in the first lesson, right? So n is just the number of data points you have. So you have 10. So n is 10, n is 10, n is 10. Next, do you know this just now? The very first formula we see today is summation x. Sum up all the x. Sum up all the numbers here. So you just sum up all the numbers here. Then you get 30. Okay. Then only u square. Okay. The square is outside 30. Then how about this? What is this? This is square before you add. You square first. 4 square, 7 square, 1 square, then only you add them together. So it will be a different number from here. It cannot be the same. Right? So once you add up all squares, then you press your calculator and you square. This is a variance. Okay, so this is variance and this is standard deviation. This is variance and this is standard deviation. So 2.45 means on average, these numbers are 2.45 steps away from the center, which is the mean, which is 3. Okay, 2.45 steps from mean. Right. Comparing standard deviations. How do you compare by looking at this? Which one has a higher standard deviation? By looking at the number, the spread of the number. This is 11 to 21. They are all quite evenly spread out. This one, only from 14 to 70, seems that everything clustered here. This one, more values on this side and more value on that side, and then center there's nothing. So by one look of all these 3 diagrams, we know that this C has the highest standard deviation because the spread is the biggest. This has a lowest spread, everything clustered at the center. Okay, so this is the biggest spread, 4.557. This has a lowest spread, which is 0.9258. This is in the middle. Yeah, this is how you comprehend standard deviations. Right. So the second, let me go back to the second. See, you know what is range. You know what is interquartile range. You know what is variance. You know what is standard deviation. Right. Okay, so that's it. That's the end for the second part. Now we move on to the third part. The third part is going to use something from the first part and something from the second part and combine, right? So we call this rule empirical rule. This empirical rule is only applicable if the shape of the distribution, the shape of your diagram is a bell shape. Yeah, so if you have a bell shape, then this applies. If not, this doesn't apply. So what is this rule? This rule says if you were to be able to have this graph here, you can find out what is the middle. Okay, so the middle will be the mu, the mean, the average, right in the middle. And you cut three sections on the right hand side, and you cut three sections on the left hand side. Then you find out the area from the first section here up to the first section here. Okay, so from here up to here. What's the area here? The whole area below this curve is 100%. Okay, the whole thing is 100%. How much is this area? According to this rule, it says 68%. From here all the way to here, 2 steps to the left, up to 2 steps to the right, the area covered here is 95%. 95%. So what about the third? From the third to the third, the area will be 99.7%. Okay, so this only applies if the shape is bell shape. If it's not, then it's not this number. Okay, right. So let me explain a little bit further. You see, this is if I have a set of data, I know the average of this population is 50. And I know the standard deviation is 10. Then where does this number fit into this graph? It will be like this. The mean 50, it is the one right in the middle. This is 50. Okay, this is the average. Then the three section I cut on the right and on the left. How big is one section? That section is one standard deviation. One standard deviation. So if this is 50 and standard deviation is 10, that means every section of this is 10. Right, so automatically you know this is 50, then there will be 60, then there will be 70 and 80. So go down, then you'll be 40, 30, and 20. Right, so this rule, just remember, you have to remember the three numbers: 68, 95, the last one is 99.7. So what I can know from this rule is if I have a data and the data has a mean of 50, standard deviation of 10, then I can say that there are 68% of the data which falls between 40 and 60. There are 68% of the data points which fall between 40 and 60. Okay, another one. We can also say that there are 95% of the data which falls between 30 to 70. Okay, 95% of data will fall between 30 to 70. And the last one is 99.7, right? So 99.7% of the data will fall between 20 and 80. Okay, so what's left? 99.7. So what is left? You only left with 0.3%, right? And 0.3%, one side, each side of the graph, this is 99.7. So each side of the graph will only have 15% left. Very small. That's why we don't draw another one section. We only stop at 3 sections. Very small area over here. Okay, so that is called empirical rule. Let's have a look at this. Now we have done mean, median, mode. We have done range, variance, standard deviation, interquartile range also. So we are going to you take out your paper and pen. We will work it out. Okay, mean, median, mode, and range, variance, and so forth. Okay, let's work it out here. You have to take a photo of this, yeah, if you don't have this number and the question. 15, 13, 10, 12, 25, 18. I'm going to transfer the number over here. 15, 13, 10, 12, 25, 18. So the first question asks us to find the mean and median and mode. So let's find out what is the mean. Right, and you can find out the mean using, go back, this formula. Right, so if you have the formula sheet with you, you can actually refer to the formula, and the first formula in the formula sheet is this, which is the mean. Okay, and we also have standard deviation formula and the percentile index I. Right, so for this topic, there are three that will be useful. So we go back to this one. Okay, then we're going to go back here. So mean is x bar, and you need to find the summation of x divided by n. Summation of x, that means you sum up all the numbers over here. Okay, you find out how many is this. 1, 2, 3, 4, 5, 6, right? So we have 6 here. What is the sum of these 6 numbers? You press your calculator. That's it. Finish. So that is mean. Median. Right, before you do anything for median, make sure you arrange the data first. You arrange the data from the smallest to the highest, 10, 12, 13, 10, 12, 13, 15, 18, and 25. Right, so if you use the first method, which is a easier method, you just take 2, 3, 1, 2, 3. So where is the median? The median is right here. Average of these two numbers, to be fair, so is 14. So I'm going to show you the optional. Or you use another one, yeah? You use the I equals to half n, or 50 over 100 n is the same, yeah? So you get I equals to half of 1 to 6, yeah? So you get a 3. What is the median? According to the rule, median will be, this is 3. So you get a third number, add up with the next one, fourth number, then you find the average. What is the third number? This is 1, 2, 3, 4, 5, 6. So the third number is 13. The fourth number is 15. And you divide by 2, which is exactly the same as that. The next one for the A will be the mode. What is the mode? We look at the number 10, 12, 13, 15, 18, 25. All numbers only appear once, so there is no mode. In mathematics, you have a tendency of writing 0 when there is none, right? But be careful, you don't write 0 here, because if you answer mode equals to 0, then anyone who looks at the the what you have written will think that there will be a lot of zeros in the original data. There's not even 1 0. So don't write any number there. You just write no mode if there's no, if there's none. Okay, you can write no mode, you write none, or you just say that all numbers appear only once. Okay, so that's how you worked out. So now we are going to go to part B. Part B talks about range. So look at this. The biggest number minus or the smallest number will give you the range, which is 15. Okay, the next one is variance and standard deviation, correct? Okay, so the variance, you look at the formula given to you here. Here's a formula. The formula give you the formula should give you the formula for S. S is standard deviation. So how do you find variance from here? Variance is a number that without this square root sign. Okay, just the one inside. So I'm going to copy the one inside, and the variance will be S squared. Okay, S is for sample. Variance S squared equals to N I'm sorry, it's not, it's inside, minus of this. Okay, S squared equals to that. So let's fill out whatever we know first. Do we know N? Yes, we know N. N is 6. Okay, N is 6. And the summation of X is 93. Summation of summation of X is 93. N is 6. This one don't know. And the summation of X is 93. Square is outside, yeah? Then this N is 6. N is 6. So now our job is to find this out. How to find? You have to refer back to your numbers, yeah? Either you use the original or you use the one already sorted. So what you do is, I'm going to use another color to write for you. You square everyone. Okay? Draw square plus dot 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 until you get what? Last number is 25. So that will give you how much? One, 5, 8, 7. You get that? So you're going to put the 1, 5, 8, 7 in here. Okay, the next thing is just press your calculator. You get 29.1. That is the variance. Then how to find standard deviation? Which is S. Standard deviation is just a square root of the variance, and you get 5.4. Right, so we have range, we have variance with standard deviation, we have answered part B. And we proceed to part C. Part C asks us to find interquartile range. We know in order to find interquartile range, we need to find Q3 and Q1. So I rewrite this so that you can see clearly. This is from the top right, so I just rewrite this. How to find Q1? Your I will be, the formula is P over 100, and it will be Q1 is 25th percentile, 6 here, so you end up with 1.5. So you don't get an integer, so you round up to 2. Okay, that means you're going to get a second position of the data. Where is the 2? So the second will be 12. Then you find Q3 I, just a colon, yeah, equals to same thing, P over 100 n, but now the P will be just 75 over 100 and 6. You see that this is just 3 times what you have earlier, will be 4.5. And it's not an integer, so you're going to round to an integer which is higher than this number, which is a fifth number. The fifth number will be 1, 2, 3, 4, 5, which is 18. So interquartile range will be Q3 minus Q1, which is 18 minus 12, give you a 6. Okay, so if you know how to do a calculation for all these measurements, mean, median, mode, range, interquartile range, variance, standard deviation, and quartiles, then you're okay with this topic. Let's go back to the slide. We have answered this. These are the key idea of this whole topic. Yeah, so if you can do this, you're almost 90% there. Yeah. So the only a little bit more is the empirical rule that you need to know also, right? Okay, now what is the last question? A random sample of 20 pizza delivery times for online orders are recorded as below. Delivery time 5 to 9 minutes, 10 to 40 minutes, and so forth. Find the model class. What is the model class? The model class, the mode is the number that appear most in the data set. But here, all your numbers are already summarized into classes. When you have lost all the number, you don't have the visibility of any of this number, but you only know that some classes will have higher number, some will have a lower number. So the class with the highest number is called the model class. So what is a model class? The model class is the model class is a class with 15 to 19. Okay, right. Now let's go to the tutorial questions. Topic 2. So you see the tutorial questions, you have question 1, question 2, question 3, and question 4 only. And each of the 1, 2, 3 has the same question as what you have done just a few ago. Mean, median, mode, range, variance, standard deviation, and interquartile range. Okay, so for all the questions where you need to do some workout and you need to write a solution, then you find the final answer. The final answer will be provided to you here. Okay, these are the final answers. Those without the final answers are the direct answer. For example, what is this data type? Is it discrete or continuous? That I didn't give you the answers. Yeah? But if you need to do a calculation, then only you know the answer, you find out the answer. All this will be provided here at the bottom of the question, and you can actually double check once you finish your homework. Right. So the homework for today is additional of topic 2. You have topic 1. Okay, I think some of you have finished, except that we have not finished discussing some of the question. We will do that in tutorial session. And topic 2 is straightforward calculation. You just try and see whether you get it. Question 1, question 2, question 3. Okay, what is the answer for question 4? Yeah, you figure out first. It is all about empirical rule.